Example 4. Find the slope of the line tangent to the graph f of x is equal to the cube root of x at 0, 0. All right, well, we just did a square root of x. We should be able to do a cube root of x. Shouldn't be that much more difficult. So we're going to set it up exactly like we set up the other one. And it's going to go, the slope is equal to the limit as h goes to 0. Maybe I should do this one as a delta x. What do you think? Let me go ahead and take an informal poll. Should we do it with a delta x or an h? An h? Okay, well, we'll do this. We'll do the next one with a delta x. All right, then. F of, we're doing this at 0, 0 plus h minus f of 0 all over h. Again, I'm just using, right up top is it's like the change in y, and the bottom is the change in x. It's the difference quotient. And now how do I get this part right here? I'll just plug it into the function. The limit as h goes to 0 of the cube root of 0 plus h minus, what's the cube root of 0? Oh, it's 0. It already told me that's convenient. All over h. And why did I write minus 0 down? Because it doesn't contribute anything to this. And neither does this 0. So it looks like this just becomes the limit as h goes to 0 of the cube root of h over h. And maybe you can see that if we plug in our 0 here, I'd get 0 over 0. And I have to fix it. How am I going to fix this one? Should I multiply by a conjugate or something? Heck no. I am going to use some algebra skills. Limit as h goes to 0. I'm going to rewrite this cube root of h as h to the 1/3 power over h. And I now have like bases, and I'm dividing, so I just subtract the two exponents. Get the limit as x goes to 0 of 1 over h to the 2/3. Sure, it's 1 minus, or 1/3 minus 1, which is negative 2/3, which means I cram it down to the bottom. And look, I don't have a 0 on the top, so it's no longer an indeterminate form. If I plug in a 0, I get, notice I put an arrow, not an equal sign, because we don't want that, because it's going to be undefined here. 1 over 0, which we associate with going to plus or minus infinity. Which one is it? Think about it for just a second. This thing down here, we're squaring it and then taking the cube root. When you square the number, it makes it, you guessed it, positive. So this is positive infinity. Now, what did we just find? We just found the slope of the tangent line. This is the slope of the tangent line, and it's infinity. What kind of line has an infinite slope? I think, wait, no, okay, so horizontal has a 0 slope, and then as it gets steeper and steeper, the slope gets bigger and bigger until I get here, and it's undefined. And the reason why it's undefined is this, because yes, slope is equal to y2 minus y1 over x2 minus x1. You have yourself a vertical line when your x's are the same. So you get 0 on the bottom, and these two x's are going to be different numbers. So you might get something like 1 over 0, which we know is supposed to be infinity. So what we just found on the graph of the cube root of x is a vertical tangent line. All right, so there's the definition here. Write it up in your notes. If f is continuous at a and, we have two different limits here. Either the limit as h goes to 0 of, and there's our difference quotient, f of a plus h minus f of a all over h is equal to infinity, or it's equal to negative infinity. We had infinity. Yeah. The vertical line x equals a passing through the point a comma f of a is a vertical tangent line to the graph of f. So here's the cube root function. You can see graphed in the lower right-hand corner, and on top of it, can you see it? It's faint. It's totally faint. There it is. It's kind of in green or something. It's having a hard time, I guess, graphing a vertical line to that point. So In other words, I have tangent lines, and as I get closer and closer to the origin, these tangent lines are getting more and more steep, and I can do it from either direction here. So maybe a tangent line here, a tangent line there, and I'm getting steeper and steeper as I get closer and closer to the origin.